Hello, my name is Erin Rene Lopez and I will be explaining solutions, suspensions, and colloids. So I'm gonna start with the Tindle Effect. What is it? Well, in 1859, a scientist named John Tyndall was born, and he asked himself a question we probably have asked ourselves when we were little. Why is the sky blue? He discovered the reason. He realized that the blue color of the sky is caused because the sunlight is scattering around particles that are found in the atmosphere, and these particles absorb all colors but blue. This is the reason why we see a blue sky. This phenomenon, he explained it with an experiment. He grabbed a cup with a liquid and inside it put particles, and then with a beam of light it shone through it, and that's how he noticed astonishing results. Notice that there were basically three kinds of classifications depending on the substance. He classified them as solutions, colloids, and suspensions. A solution is a homogeneous mixture by a solvent and a solute. It can be solid, liquid, or gas. Then suspension. A suspension, on the other hand, is a heterogeneous mixture that has bigger particles. Normally, but not always, suspension has something called sedimentation. Sedimentation is when the particles are so big and so heavy that they go down to the surface of the glass they are in. And finally, we got a colloid. A colloid is not too big and not too small. It's like the middle of a solution and a suspension. It's a homogeneous mixture, does not have sedimentation. So now I will be performing and explaining the experiment I did. So in this experiment I made three mixtures: hot chocolate, water with chia. By the way, chia is super healthy for your stomach. And lemon with water. After doing the three mixtures, I turned off the light and shone each glass through a beam of the flashing light. Based on the previous knowledge in this presentation, I can conclude this is a solution. Now the next glass, it is the water with chia. I even had to stir it. This means it had sedimentation, which makes me conclude that this substance is a suspension. Finally, the hot chocolate. Here it's clearly seen that the light does not go through the liquid, which means it is a colloid. Thank you for watching.
Hello, my name is Sofia Salazar Rivera from the group 316, and I'm going to be explaining and showing an experiment of the topic solution, colloids, and suspensions. A solution is always transparent and does not settle out. It cannot be filtered but can be separated with the process of distillation. Water and salt are an example of a solution because they have very small particles and they dissolve. A colloid is an intermediate between suspension and solution. It is visible to the naked eye. It can be distinguished between solutions with the Tindle Effect. The Tindle Effect is defined as the scattering light of a colloidal solution. Milk is an example of a colloid because it has large particles and it cannot be separated with a filter. A suspension is defined as a homogeneous mixture and their particles are very big, so this makes it visible to the naked eye. In this type of mixture, all of the components are completely mixed and all of the particles can be seen under a microscope. Since their particles are very large, this allows them to be filtered. If a suspension is allowed to stand, then the particles will separate out and this will create layers. Water and oatmeal is an example of a suspension because there are two molecules and the oatmeal goes down.
Hi, my name is Giovanna and I'm going to make an experiment about the first stage, specifically the topics of chemical reactions and some evidences of it. Well, first, what is a chemical reaction? A chemical reaction is the process by which the atoms are rearranged to form different substances. And some evidences of them are changing color, formation of gas, precipitation, changing temperature, that it can be released as heat, And well, I specifically going to make an experiment about the formation of gas. In this case, it's going to be the effervescence. And the effervescence is a chemical process that consists of the reaction of an acid with a sodium carbonate or bicarbonate, giving off carbon dioxide through a liquid. That's why the bubbles that we see are produced. And well, these bubbles are produced by the effervescence of dissolved gas, which itself is not visible in its dissolved form. Well, the effervescence reaction is this one that is right here. Although, well, in this reaction there is no release of carbon dioxide because the effervescence comes later as carbonic acid at room temperature and is transformed into carbon dioxide as this chemical equation. And well, my experiment is about pickled grape salts dissolved in water. And well, here I have the glass of water and here I have the pickled grape salts, and I'm going to pour them into this glass of water so you can see. As you can see, there are a lot of bubbles right here, like there. And basically, this is the effervescence. Okay, so pickled grape salts are basically sodium bicarbonate, tartaric acid, and citric acid. The reaction that occurs when diluted in water here is this following. For example, well, we're going to explain the reaction of each element. First, we have the sodium bicarbonate that reacts with water and produces sodium hydroxide and carbonic acid. This is the equation. Then the tartaric acid with the water, it produces carbon dioxide and water. This is the equation. And at the end, the citric acid plus the water produce calcium citrate and hydronium. That is this equation. Thank you for watching.
Hi, my name is Ana Valeria Arevalo de Leon. I'm going to be doing the experiment about a pH, specifically the red cabbage juice experiment. First of all, what is pH, right? This is a measurement, as it can be said, that is a scale that once that it starts at a 0 and it goes up to 14, 0 being the most acidic part of the scale, and there is a neutral part that it is at 7 of pH and 14 being the basic. Well, then what is the red cabbage juice and how does this work? The red cabbage juice or red cabbage is a natural indicator that has a blue pigment that this has the ability to change different liquids depending on their pH. So well, we have four liquids that we're going to measure. First is the lemon juice that has a pH of 2.16, then black coffee that has a pH of 4.96 or 4.9-ish, then vinegar that has a pH of 2.5, and milk that has a pH of 6.6. And well, this is the red cabbage juice. So this is pretty easy. We just need to put the red cabbage juice into the container of each liquid. So let's see. And it's supposed to, as you can see, change its color, right? because it changed the pH of each liquid. Now we continue with the black coffee, and well, there it is. Then the vinegar, and lastly the milk. Well, as you can see, each of the liquids change its color. And well, finally, we have the lemon juice after putting the red cabbage has a pH of 2.3. And well, as you can see, it obviously changed its color. Here you can going to see the scale, so you can see like in what part of the scale is. So it's basic or acid. The coffee, it didn't change a lot its color, but well, neither its pH, because it's just elevated a little bit because it's 5-ish, and the vinegar, it also changed its color, and in their pH changed to 2.5. Well, it doesn't change. And the milk, that it become like a purple color, and their pH is of 6.5. So yeah, that's it. Thank you.
Hi, I'm Fernanda Morales Cavazos from Group 316, and I'm going to show you some ways that you can perceive that there is a chemical reaction. So, in this experiment, we're going to mix baking soda and vinegar, so we can see how these two things react by mixing them. So, we're going to mix them. As we can see, there are some bubbles, and there's all that you can perceive. There is no heat, there is no change of color, and there is no other things. There's only the bubbles. So that's the experiment. Thank you.